Thank you for a very, very generous introduction. It's a privilege to be here. Almost 10 years ago, I was an undergraduate in the computer science department at IIT Delhi. During that time, my colleagues and I participated in a very interesting course where our mentor, Professor Balakrishnan, challenged us to identify a real-life problem and work upon that and develop a functional solution to solve that. Looking for an interesting problem, I landed at the National Association for the Blind in Delhi and met a remarkable person called Mr. Dipendra Manocha at the technology division. And I said, well, we're good at hardware and software and we can build systems. Is there a particular challenge or an unmet need that we could work on? And he said, yes. Well, independent mobility for a visually challenged person is a day-to-day problem. They use the white cane to detect obstacles on the ground. But this folding cane has many limitations. It can only detect obstacles within a close range, very close by, about 50 centimeters, and it cannot detect anything from knee till head height, like an open window in a corridor, or a side of a vehicle, or a railing, and you only detect something when you come in contact or you collide with it. So that's like walking in a minefield. You suddenly encounter an obstacle, and then you have to change your direction awkwardly and then move on the side. This constant fear of getting collided and getting hurt prevents many people from even stepping out of the house. So when we heard that, we were really shocked. We said, well, with today's technology and sensor technology that exists, a solution must be possible. So we then spent time observing people how they actually use the cane and what are the problems that they're really facing. And and as we went around, we saw that there are many, each one of them has stories to tell, and when they've been hit on the forehead, and parents would tell that they're very scared to even send their children to schools or colleges. So we were trying to think of a solution. We said, well, can we mount a small detachable unit on the cane which has a sensing capability? It produces an ultrasonic beam which gets reflected from obstacles in front, and then the user is informed through various vibration patterns that change with obstacle distance, allowing the user to detect much before coming in contact and then determine a safe path around it. And what started as a simple idea eventually transformed into the device called the Smart Cane device, which is a reality in the hands of the users today. Our first attempt was very simple. We started looking at how the canes are held, how they are used, and developed a small little sensor box, which had a sensor and it had a vibration capability. And interestingly, even with such a crude prototype, people were able to do path finding. So high vibrations one side, less vibration in the middle, and you could actually find a path and make your own way without colliding with the people on the sides. Then people said, well, this is fairly bulky. Can you make this as a handle-shaped unit? And we got support from Professor Rao's lab in the mechanical department, and we were able to fabricate some of these designs. And interestingly, people were able to detect obstacles much before coming in contact. So a side of a vehicle could be detected 3 meters before they come in contact, and a raised railing also much before coming in contact. And that, for a visually impaired person, is almost like magic. How can you detect something when you've actually not collided or touched it? So the people who tried the unit then told other people to try this as well. And gradually, we had about 30 users who had used this by 2007. One day when we were testing at the National Association for the Blind, a mother walked to us and said, well, I've been seeing you coming for almost a year and trying different prototypes. My son is in class 5. When can my child use your technology? And I didn't have an answer at that time. We were in this classic problem of having a prototype which is user validated, but the real challenge is how do you take this prototype into a product? Because a product means much more. It means that it has to withstand varied use. It has to be used in a variety of settings, must be high quality, robust, and reliable. And that's a difficult journey to go from a prototype into a product. Many innovations fall in this problem of this valley of death, where it's difficult to transition from a prototype into a product. What you essentially require is large-scale user studies, as well as industrial R&D and looking at the manufacturing aspects to make it really happen. We had to think differently. Our capabilities, so we formed an interesting alliance called the Industry, Academia, Nonprofit Alliance with a manufacturing partner called Phoenix Medical Systems in Chennai, with a user group the Saksham Trust, funded by an international charity called the Wellcome Trust, that allowed us to take this project forward. And with this team, we were able to travel to different parts of the country and study users, their varied use, how they hold, how they carry, how will they transport, as well as the scenarios of use. So particularly obstacles in real life, for example, the signboards, as well as size of vehicles, small bars, iron, wood, whatever had to be detected. And that gave us many inputs for our R&D activity, and we were able to do several design-build test cycles to overcome these issues. Here you see the development of the grip, where different holding styles are being observed, different pain points are being identified, and eventually the prototyping allowed us to reach a particular unique grip that we have today. A design itself is not sufficient. It must be manufactured. And we have to look at the manufacturing aspects in terms of quality and to assure that each one of these smart cane units can withstand the rugged use that it is required for. And with all of this, gradually we started seeing the device that we see today. So this is the smart cane unit. It fits on the top fold of the white cane. There's the grip section, and then there's the forward sensor area, and this is how the tapping is actually done. So it really is a complement to the traditional cane usage. If there's an open area, then I can gradually tap with a very shallow angle, and if there's more crowd, then I can bring it closer to my feet. I can adjust the angles to compensate for the detection beam. In case the cane breaks, for example, it gets into a cycle spoke, or somebody steps onto it and the cane breaks, I can detach it easily from the unit and replace it. There's also the indoor and the outdoor mode. Indoor, we are very familiar with our environment, so we can reduce the range from a total range of 3 meters to about 1.8 meters. But functionality enough is not sufficient. There are many other usability requirements as well. For example, the requirement that it should fold like the normal cane and pack up so simply that I can put it in my pocket. Or it can be put in a purse as well. Beyond that, one of our users from the Center for Blind Women suggested that we make a little pouch in which we can put the entire folded unit so that the soiled cane does not soil the other articles in her purse. So this is a little design that she herself designed for us, where the entire unit goes in, and very nicely we can carry it, and even say if it starts raining, she can actually remove the unit and put it in this pouch and store it easily. Our users wanted to learn the operation of this device without any sighted assistance. So we had to design a little braille manual that takes through the process of what are the basic functions of this unit, and how do you start using that, standing in front of a wall and observing these vibration patterns, and how do you use that in your day-to-day mobility. Because ultimately, it's about dignity. It's about independence and the fact that they should be able to operate and maintain this device without any external support. All of this had to be at an affordable cost. So the SmartCane device comes at a price point of 3,000 rupees, a fraction of the cost of international products. But affordability and low cost does not mean low quality, and it adheres to the same quality standards, the international CE mark and ISO standards, which are common for other international products. So after building this unit, we took it for testing at an obstacle course. It was a 200-meter area with about 20 obstacles, and 30 users first went through the white cane and then with the smart canes. Here you see a user walking and then colliding with a barrier, and then he has to negotiate that obstacle and move on the side and figure out a path. And then he encounters a raised obstacle, and then sort of clumsily has to move around and compensate another overhanging obstacle where the entire cane has got underneath. Now let's see the same example with the smart cane unit. See, the detection has already happened. The person gracefully stops, reduces the speed, goes on the side, and starts moving beyond this. As he then encounters a raised obstacle, detection has happened, he does not collide, and moves away gradually. See another example, very clean detection about 2 meters from the obstacle. We observed almost 93% decrease in the average number of collisions on the path. That was tremendous, almost twofold increase in the average distance at which these obstacles were detected. And finally, it was time to take the device to the user. Here you see the person reading the braille written on the top of the box and learning to operate the use, opening up the stick and starting to use. One more ingredient which is very important is the training aspect. Here you see our special educator taking a class, a small number of users, explaining how the different parts actually work. And that is also necessary to ensure that technology is used in the correct manner in the day-to-day mobility. But can only sighted trainers train? The answer is no. Our best trainers have been the persons with visual impairment themselves. Here you see co-training happening where the different parts are being explained, a person taking another visually impaired person for a walk and describing how these vibration signatures are going to change with the different dynamic obstacles. Sometimes we had to develop some novel tactile representations like the one you see below, which allows a person to understand the spatial concepts like the detection cone as well as distance at which these vibration patterns are changing, and that also needed an innovation. But how does it really work in a real life setting? You see examples from 6 cities. You see our user Sadhguru in Delhi now negotiating a protruding tree branch. This is an example from Bangalore where she's trying to find the gate with high vibrations and less vibration and then going through that one. Then there's another example where a low vision person is explaining to another person that how these vibration signatures are changing from a special educator who's standing in front. This is an example again in Delhi where a person is walking, encounters an obstacle, changes the direction, and then moves forward. Just look at the confidence and the straight back, and it's really wonderful to see such an example. Our users found many interesting examples of utility for this technology, which we did not anticipate initially. One of these is the overhead signboard that you see very cleanly getting detected. The another one is a user encountering a cow and then stopping before coming in contact. And you see bad things can happen if you poke a cow with a stick or you collide with it. Another interesting example is following a cue, that you can stand at a safe distance with constant vibration patterns and not poke at the rear of a person who would actually turn around and say, what are you doing? Right? So many of these non-contact detection aspects were very important and gave our users a lot of small applications for this technology. But ultimately, it's about improving confidence and safety in your day-to-day life. These results were consistent in our field trial conducted in 6 cities with 150 users, and we trained them with a standardized methodology, gave the unit for evaluation, and after 6 weeks, took the feedback. 93% believed that their safety and confidence had improved, and almost all of them refused to return the field trial prototypes and said that we've now totally shifted over to the smart cane beyond these trials. The product was finally released to the people in March 2014 and is now available nationally with 50 partners, 20 states, about 5,000 units in distribution and increasing quickly. In order to reach the farthest and remotest parts of the country, we required a multi-pronged approach. So the unit is included in the Government of India's national program, the assistance to disabled persons in purchase of technology devices, and is reaching the base of the pyramid. Philanthropists are also coming forward to provide access in their local region. Media is supporting us to get the message across and to get the message about the different schemes under which it is available to really scale impact. But what does it really mean at a day-to-day level? This is our user in Bombay. Her name is Indrani. Indrani is in St. Xavier's College, and she uses the device daily to navigate. So we followed her in the morning. So she walks across, encounters a tree, takes upper arm protection, doesn't collide with it, walks forward, and then encounters a little letterbox. And you see a very clean detection, does not collide, moves forward, maintains then a constant distance with people who are walking in front. This is gate detection example again. So we asked our family as to what has really been the impact of this. And they said, well, earlier we were very scared of sending Indrani alone to her place of work. Now she goes out on her own and is much more confident with this. These are our 3 special users. Yogesh was involved in the development process. Sadhguru commutes about 20 kilometers daily with this. And Anil has become now a trainer and also handles our user queries and helpline, our training and dissemination program. But in this journey, what were the key lessons that we learned? I will share 5 of them. Number 1, a deep understanding of disability, what it means to be a disabled person in India. Blindness stems from the loss of the visual system, but also includes the other dimensions of poverty, stigma, exclusion, and eventually it's the environment that disables. And technology can play a tremendous role in preventing an impairment from becoming a handicap. The second lesson for us was the importance of involving users, right from specification into design, development, validation, as well as the dissemination activity. SmartCane really is not an IIT product, it's a people's product. Over 300 users, 50 organizations have contributed at various stages of development, and is the primary reason why we are seeing adoption at scale today. Third, the importance of rigorous research and validations. Research methods can be very powerful in understanding the user needs and scenarios of use. Quality assurance is only possible with very rigorous testing in the lab, according to quality standards, and field trials are necessary before a technology can be released and scaled up in the national program. No one individual can do this alone. We were blessed by a fantastic team spanning different branches of engineering, researchers, special educators, designers, industry, and that group, is the collective that made this happen. Sometimes institutions must come together and contribute their core strengths to achieve a larger mission. And finally, it's about perseverance, it's about passion, to take an idea and see it end to end as a product, a reality in the hands of the users. The SmartCane is a very small example. It's a humble tribute to the Mahatma, who inspired innovators to harness science and technology for the betterment of society. But having said that, is our work finished? The answer is no. Our work is not finished till every blind person can walk with safety, confidence, and dignity with a device like the SmartCane. We've only reached a few thousand. There are many more millions in India and beyond that in the developing world that need access to this technology. Our institution's work is not finished till there are technical needs for persons with special needs in many other areas, not just mobility, where we've made some impact, but also in education, employability, independent living, and so on. Our lab at IIT Delhi has made a very small beginning, but much more needs to be done. And our nation's work has not finished till every person with disabilities is included and integrated in the mainstream and has equal opportunities to excel. Let us remember what the Mahatma said, that a nation's greatness is measured by how it treats its weakest. Thank you.